Hi, everyone. Great to be in this this first virtual space with you. We're gonna depart from the GAN train here for a little bit. Thanks for the opportunity to share our Easy EC tool with you, and that's making embodied carbon easy. First off, our team here. So my name's Luke. We've really lucky to have an awesome team located all around the world. We got 7 of us in total from 3 countries across 9 time zones, and a really nice mix of architecture, engineering, computational design. It's a really great group. We got together on Friday really with a goal of approaching this problem of embodied carbon, which is sort of recognizing and appreciating the fact that we as designers have a significant role in our buildings contributing to greenhouse gas emissions, and also recognizing that the time to make pretty significant changes to meet the 1.5 degree targets carbon budget based on the Paris Climate Agreement are pretty short. So in the span of 24 hours, we had this kind of very large goal in mind. That's where I'll hand it to Chris.
Yeah, so I think we're all fairly familiar with this chart of showing, throughout the design process, as we get closer and closer to construction, we have less of an impact on what we're able to do. On the next slide, we see that most of the embodied carbon calculations happen around here, whenever we're in construction documentation and starting fabrication and actually building the building. And it's great that we're starting to do these embodied carbon calculations more regularly, but they really have very little effect on the actual building. And so on the next slide, what we get really are these kind of ranges, and what we're able to do with that is determine, perhaps less intensive products to implement in the building, like switching out concrete or drywall or something. But what we wanted to look at was how could we push the embodied carbon calculation earlier in the design process and actually think about it during the massing or conceptualization of a project. That actually works pretty well on the next slide. Because we know that about 70% of the total building embodied carbon comes from just the structure and the facade of a building. And so we're able to generate a lot of that information pretty quickly through massing, and either interpolate structure or figure out massing through approximation, and then get some pretty quick numbers to help us guide embodied carbon. And Brittany's going to talk a little bit more about the methods we used for that.
Yeah, so with that being said, this is the engine that provides a rough embodied carbon quantity estimator per se. And so what you do is you take your material quantity and then you multiply it by the material area or volume, and that'll give you your estimate. So on the next slide, you'll see our logic. So what we ended up doing is we broke down the material into the facade and the structure. And so using EC3 to verify some of those quantities, we were able to compare and get an estimate there. And also we utilize the BOM application to inform different components for material calculations and estimating different values there. And being able to compare it to, if you go to the next slide, Kaleidoscope. So this is a tool that evaluates embodied carbon and the life cycle assessment to measure the environmental impact, which includes material selections. And so this is what it does is it is an envelope calculator, which allows the user to set custom settings by picking a wall assembly and compare different global warming potential factors to inform the design. So it's a cyclical process of putting in information or real assemblies in order to understand what the GWP is going to be. And later we can provide a link to encourage you to check out these tools. Thank you.
We integrated a bunch of existing tools and frameworks targeting different types of users. The line on the bottom of the slide shows progression of user friendliness. Grasshopper tool is a kind of engine driving our investigation. It requires significant amount of skills and knowledge from the user, but allows the user to customize the method and validate our mathematical model themselves. Is extremely flexible. Next slide, please. On top of that, we have a human UI interface that even a less experienced user can operate. And progressing further, we have a Swarm app that Emil will speak to.
Yes, thanks. So at this point, we had a pretty good backend with the kind of human UI layer that we're sort of able to extract out some of the complexity within the Grasshopper definition. But it didn't entirely disconnect the user from the complexity of the environment. So you would still have to have the Grasshopper definition, know how to run it, have the local set up with the plugins and everything. And part of this goal is obviously to actually make these kind of tools accessible to broader audience, so to speak. So here's a little Swarm app that we built. So Swarm is a system that allowed us to take this Grasshopper definition, push it to the web, and then access all that logic from the browser. So here on the left, you see the inputs of the app. So you got some inputs for the sort of property borders, area ratio, inputs about the floors and layouts, facade glazing percentages, and outcomes actually the global warming potentials for the different systems of the building. So next slide. A limitation of the Swarm app was you can't actually modify the input geometry, right? So here is the same Swarm app actually, but running inside of Rhino, which allows you to sort of modify some of the input geometry. So, I mean, this app was really good for kind of early stages, but you don't actually have any kind of specific control over the, the massing geometry. So I believe my friend Luke will say a few more words about that.
Yeah, so when we started out designing this as a UI, I think Swarm made a lot of sense in the end, but we had come up with something similar to this, where it's just a lot easier for really any user to use a Grasshopper script on the web and just have a couple of different inputs on the right-hand side there that they could change out interactively and see sort of an updating donut chart. And then, so this felt like something that was limited to several different constraints, but potentially you could download a Rhino file from here. And so on the next slide, this would be sort of the companion app where you could then upload any Rhino file, and it would then be able to be categorized into different wall assemblies, and then you could start to understand your model without having to extract all the individual surfaces and potentially even compare them against each other. So this is sort of the framework in which I'm going to present sort of this final tool, which can be found on the next slide. And so that's the link, but instead of doing a live demo, we'll just go ahead and show this quick video that I'll narrate. So yeah, this is if you go to that website, this is the tool you'll see. It's a 3D model viewer that you can essentially, we have some placeholder Rhino files up there now. But yeah, we also iframed in the Swarm app as sort of the companion to this, because we do see them very much linked together and all the controls between them are the same. So this is like really early pre-design phase where the building viewer is something that you've designed. And then you can actually start to assign all the different materials. Half of them are coming from the Kaleidoscope app, and then half of them are actually coming from values extracted from within the BOM tool. So we were able to sort of leverage two different sort of bleeding edge technologies here to make one singular sort of metric that you can view your designs. And so this then changes the global warming potential that you see on the side there, updates the pie chart, excuse me. And up at the top, we could then sort of cycle through the different design options that are loaded. Unfortunately, at the last second, the pie chart stopped updating, but that's something that we were hoping to do. And same with adding in your own Rhino file. Very, very close to having that work, but just at the last second, that didn't come to fruition. But that's the whole goal, that anyone with no Rhino, no Grasshopper experience can come to this tool, download a file, upload it, and start to really understand the impact of all their different materials choices.
Yeah, thanks, Luke. And I think one really nice aspect of this that is potentially overlooked and other tools that are existing is incorporating that facade into the calculation. And a quick shout out to Luke, he just released that Kaleidoscope tool with Payette this past week. So that's really exciting to get those components in there that people can quickly and easily assess the facade. And really the other benefit is bringing this to a broad audience, making it open source that anybody could use in an easy user interface. Oh, there we go. So I think that kind of sums it up. We have a lot of ideas how you could build this out. There's a lot of potential to kind of incorporate variability and benchmark buildings to give more tools to designers. But really, this is, I think, a great first step. I'm really proud of what we put together in such a short amount of time, and hope that it's something that people can build upon. So with that, I think we close it and answer any questions. Oh, here's the GitHub, by the way. Yeah, can someone paste that in the chat?
Awesome, thanks for that. So I have a question regarding sort of how one might kind of break up a facade, or sort of the level of granularity that a designer might want to include in the study, and how you guys were thinking of sort of managing that.
Yeah, I can answer that question. That was something that the Kaleidoscope tool was really focused on. So we were able, I mean, I don't know if you're sort of aware of it, but it actually tries to make an apples to apples comparison across different facade types. And so they've actually considered all of the different facade elements within that system. So it's not just looking at, the metal in an insulated metal panel facade, but it's actually looking at the entire wall buildup down to, the paint and finishes. So that's something that's sort of existing that we just get to take for granted, essentially.
So in terms of let's say we had like a surface, and I guess maybe this is something that I need to kind of understand a little bit better about your process here, but like, how does one, say, assign like a certain chunk of a facade to have certain properties versus another one? Like if I were to split a facade into two and say, the bottom half of this facade is one materiality, the top half is the other, how do I kind of make that move and kind of get that information into your tool?
Yeah, great question. I'll take this one again. So I think that's why we had sort of the follow-up portion of the tool where you can upload your own Rhino file. And when we had initially sort of envisioned it, we would make you download a template that was set up in a very certain way. And that just felt pretty cumbersome. And so we were able to actually essentially take whatever layer structure you have in essentially any Rhino file, upload that, and it just sort of parses every layer. And as long as your file is organized by layer, you can then in the app assign any material to it. And so, I mean, it's definitely a more advanced feature, but I think it's important to also have that first step where if you don't necessarily know all the different elements of your facade, if it's sort of pre-designed, you can still get metrics using the first tool that was presented.
Awesome, thanks.
Yeah, I don't really have questions, but to comment, like it's super cool. Like on the first hand, like the fact that it is thesis driven, like, is quite engaging. And like the just stating that like you want to address the early design phase and move the energy calculations, or at least evaluations, early on. So that's a great conceptual move, and also these kind of web service ideas, and like the idea that it can be a web API in a way, like that's also cool, where you can upload your own Rhino files, and so potentially it could easily become a web service, presumably, if you didn't want to upload the actual Rhino file, but just send in the parse data, like whatever parser you can run the parser locally, so that it, most people wouldn't want to upload files. So yeah, just these two comments, I think like these tools have like a great potential, like and far greater impact, like really at the early stage of design, where mostly 80% of like most savings, any environmental savings you're likely to make it probably happens in the first 2-3 months of design. So yeah, great hack.
Yeah, I would also like to follow up on this because our office is really looking into this. It has been doing this for years, and we're doing a lot of research into all of these LCA tools that are out there, trying to figure out if it is actually early design stage that we do the changes, or if it's just after that, because there's so much chaos happening in the beginning. I was more interested in also, so the feedback, that's the donut that gives you data. Is that correct? That gives you some outputs. We are talking quite a lot at the office about if it could be interesting also because it's a teaching exercise for the architects to learn to draw with data, that maybe the feedback could be at geometrical suggestions again, maybe less columns or different columns. I don't know if you thought about that. I know that's very difficult to do in like 24 hours, but I don't know, again, giving a bit of context to your idea on this tool here, because I think it's very interesting as well, as Sajas is saying.
No, that's a great question. Thank you. And I think it dovetails well with a question from Theodore in the chat about structure. And as part of this tool, we did program some very basic structural intelligence, if you will, depending on system and depending on the column span. And I think that very much is an important piece of the feedback loop, because those basebands really drive structure, and they can also inform like floor to floor depth, right, is really important, and number of floors you can get. Yeah, obviously there's more there, and some other folks like Asterix also estimates those structure sizes. But another interesting idea that Andrew from our group was talking about is also studying, like, can you build less, and getting into kind of having that information, because we're measuring it, it does make you think about it more, right? And makes you second guess, what do I really need, right? And it's just more information to make those informed decisions for your client or whoever cares about it, right?
Yeah, exactly. We still don't know what is right and wrong here. I think this is a very good suggestion. So I'm definitely going to show it to my team as another proposal as well. So thank you.
Cool, thank you.
Yeah, listen, I had similar questions to what Theo and Ken had to say. And I think a nudging kind of approach is very good for designers in the early stages. So have you thought about this, or can you do this maybe? If you are set on concrete, what about changing it? The facade to a different method or something like that. But it's basically answered. So my questions were very much on suggesting or nudging the designer to use a different method or better performing method.